Hello, good morning. This is Titus. I'll be doing a video on in linear algebra on kernel transformation. So this is the question on kernel transformation and the solutions. Also, I'll target subspace. Yes, subspace and how the vectors they span. So continue watching my videos, subscribe, like and share. Question, they are saying let t be such that R2 maps to R3 be defined by a t that is t of 1 to t of x1 and x2, and then x1 again, x1 plus x2, x1 plus x2. Then they are saying you should find the kernel of this. So the kernel of this, we always say that t of x1 and x2 should be equals to what? Should be equals to 0, like that. So if you write this, it means our x1 there should be equals to 0, and our x1 plus x2 is equals to 0. Again, our x1 plus 2x2 should be equals to 0. So we know that our x1 is already 0. So let's find x2. We'll just place in. So we'll say our 0, we are getting this equation 2 plus x2 is equals to 0. So meaning our x2 also is what? 0. So now upon finding that, we'll just say if that is the case, then we'll say the kernel of t equals x1 and x2, which is equals to what? 0 and 0. So the main essence of the kernel is to find the solutions, the values of x1 and x2. That was the main essence. Another question, determine whether is a subspace or not. So this question is very simple. Mostly timacha observe vector iri mukati. So I'll say this again. I'll say this. In this case, monga mamene iri equation. So very simple. You just say let 0, my marker, let 0 be a member of what? Of R. What it means is that R should contain a 0 vector. The language here pachitika. So this implies that we have this vector 0, 0, 0 should be the member of R. If it's not the member of R, then it's not a subspace. So we'll say this implies that let A equals 0. A area equals 0. So if that is the case, then I will say I'm getting this A. This A. I'm getting this this vector here. Sorry. Yeah. This vector to be A, 1, 0. So I'll place in papali n is equal 0, 1, 0. Now I have this mathematics. This is not a 0 vector because pali 1 pakati, but therefore it is not the member of what? R. Henceforth, therefore not a subspace. Not a subspace of what? Of R. So this is how you conclude it. Roman numeral 2 of the question says W open bracket X, y is the member of R2 where x squared and y squared, where x squared is equals to y squared. So here what you are doing, we are proving the subspace. So to prove this subspace, I will say it should contain a 0 vector. So I will say 0 should be the member of R. Then from there I will say let x equals 0 and y equals 0, such that we have the vector 0, 0 should be the member of R. And then if such is the work, then we'll say this implies that the x squared equals y squared. Then we can take the x squared, the y squared the other side, so that we have 0. So I say let x equals 0. So if I say 0 squared minus 0 squared is equals to 0. So meaning 0 is equals to 0. Since it satisfies this condition here, therefore it contains a 0 vector. It contains a 0 vector, and then we'll say let u, v be the member of R, such that u plus v, they are also the member of what? R. So the v and the u, they are vectors in the vector space W. So what are we going to do here? What we'll do here, we'll say if such is the case, then we'll say we will let u should be equal to x1, y1. Again our v should be x2, y2. And when you retouch this point, you just say you satisfy this condition, the addition, the 0 vector already satisfied. So what are you going to have? You have x1 plus y1, then plus x2, y2. Everything should be the member of R, like that. And then from there, what are you going to do? You just add. So you have what? x1 plus x2, and then y1 plus y2 should be equal to the member of, should be the member of R. This expression shows that this is in 2 dimensions because we have this. So there is a coordinate here and there is a coordinate when you add them. So from there, this shows that we are still in R2. Then from there, you multiply with the scalar. You say, multiplying with the scalar, the last part u should be the member of R. So that when I multiply a scalar to the given vector x1, y1 should be equal to, should be the member, R. This means that alpha x1, alpha x, y1 is the member of R. Now if you have such, if you can satisfy the 3 of them, then you say therefore therefore W is the subspace.